Hello, I'm so glad you're here so we can do some more calculus. Today we are on to daily lessons 193 and 194. So in this problem it says given below are differential equations with given initial condition values. So differential equations, don't be scared off by this. This is just saying given below we've got a derivative and then we have initial condition values, meaning we have a point from the original function. So the derivative, a point from the initial function. That's it. And then find the particular solution for each differential equation. This phrase is the clue that we're like, oh, this is what we do next. We have to find the antiderivative, and then we have to put in the original x and y value, in this case -1 and 2, in order to find my value of c. So let's actually do this thing. So these are separable differential equations, and what I mean by that is that I want to get the dy over here, and I'm going to multiply both sides by dx. So if I do that, I get dy is equal to 6x squared plus 6x plus 2 times dx. So I multiplied this side by dx, and the x's would cancel out this side by dx, and I would be left with this. And so what I'm actually doing is now I can integrate both sides of this equation. So I've got the integral and the integral. And so now this looks like something that we would have had before, except now we've got the integral of dy on one side and this integral on the other side. This side doesn't have a function, or at least it doesn't look like it. So I have to think about what is multiplied by dy here. It would just be a 1. The antiderivative of 1, normally we would think of as x, but in this case we're just going to say y. And I don't even need to put plus c on this side because I'm going to put it over here. And so as long as I put the plus c somewhere in this equation, it's fine. Because if you add a constant on one side, add a different constant on the other side, you subtract them, you still get a constant. So, or you subtract one thing from both sides, you still get a constant. So you only have to do the plus c on one of these sides. So I've got the antiderivative of 1. Because this is in terms of y over here, this is dy, I've just got an antiderivative of y. On this side, we're going to do it the same way as we did before. We're going to say add 1 to the exponent, divide by my new exponent, so 6 divided by 3 is 2. Add 1 to my exponent, I would get x squared. Divide by 2, I would get 3, plus the antiderivative of 2 is 2x. And then you can't forget the plus c. If you forget the plus c, you're going to get stuck and not be able to do anything else after this step. Just to make sure that you've got this right, you should check yourself. So I'm taking the derivative, so I would have 1 here, which is what I have, and this would be 6x squared plus 6x plus 2. Okay, I'm good, plus 0. Now I can take this original point, this is an x value, this is a y value, substitute in. So I'm putting in -1 everywhere I've seen an x. 2 for y. And now I'm just solving. So 2 is equal to -1 to the third power would still be -1. So I've got -2. -1 squared is +1, so plus 3 minus 2 plus c. And then probably the hardest part of this is just making sure you don't mess up any algebra. -4 plus 3 would be -1. Add -1, well, actually, I don't want to get into the habit of just doing a bunch of steps in my head. So I've got 3 is equal to c. So when this problem asks for find the particular solution for each differential equation, I was given a derivative, I was given a point, I work backwards until I get to the original equation, which I'm going to write as y is equal to 2x cubed plus 3x squared plus 2x, but now I know c is 3. Ta-da! We did it. We found the particular solution for each differential equation, or at least for the first one. Let's do more. I'm like, okay, this one doesn't look that nice. So is there some way that I can simplify this one first before I do any other fancy business to this? This is the same thing as y, or 1 plus 12x to the 3/2. And then I can divide each part of this by 2x to the 1/2 power. Well, if I take this and I divide that, that would be the same thing as saying dy dx. And I could break it up and divide each part of this fraction by 2x to the 1/2 power. So that really means dy dx is equal to 1 over 2x to the 1/2 power, but the same thing as 1/2 x to the negative 1/2 power. Over here, try it real quick, what would you get? 6x. If I subtract the exponents, 3/2 minus 1/2 would be 3/2 minus 1/2 would be 2/2, also known as 1. So I'm just going to leave it like that. And now we can start the same process that I did over here. So I simplified it. Now I'm going to get multiply both sides by dx. Now I can integrate both sides. The antiderivative of 1 dy, because that's all I'm left with here, will be y. I'm going to add the c on this side, so I don't need to do it on both. This would be x. Negative 1/2 plus 1. Negative 1/2 plus 2 over 2 is the same thing as positive 1/2. 1/2 divided by 1/2 is the same thing as me saying 1/2 times 2, which would just be 1 out here. You can write 1 or just leave it like that. Add 1 to the exponent, divide by my new exponent, and then don't forget about plus c. Now what? Here's my point. This is my x value, this is my y value, so I find 2. X to the 1/2 is the same thing as me saying square root. So square root of 0 plus 3, 0 squared, plus c. Oh, that's nice. I know I just get 2 is equal to c. So I'm going to say c is equal to 2. Therefore, I'm going to go back up here. You can write this as y equals x to the 1/2. You can write the square root of x. Doesn't matter. Plus 3x squared. What does matter is that you substitute in 2 for c now. Okay, so not so bad. Both of these, I just had I integrated 1 dy on this side. That's not going to be the case down here. Down here, I need to get the y's on the same side, the x's on the other side before I can even begin. So I'm going to multiply, so I get 2y dy is equal to, then over here I'm going to have x squared plus 2x dx. So before I can integrate on both sides, I need to make sure that I am getting all the y's on one side, all the x's on the other. Now, as long as I do the same thing on both sides of an equation, I'm good. Just like before, if you add something on one side, you have to do it to the other. Here, if I integrate on one side, I must integrate on the other side of the equation. And now I want you to think about, in the last one, we just integrated 1, and we got y on the left-hand side. Here, we're integrating 2y. What do you think this could be? Think about if we integrate 2x. That would be x squared. So 2y would be, or integrating 2y would be y squared. And you can check yourself by taking the derivative. So the derivative of y squared is 2y. Again, I don't need a plus c because I'm going to put that on the right. Go through this process again. X cubed now, because I added 1 to the exponent, divide by my new exponent. Add 1 to the exponent, divide by the coefficient by my new exponent. Don't forget about plus c. Now what? You sub in a value for x, you sub in a value for y. So in this one, I'm going to sub in, this was 2 squared is equal to, this is going to end up being 0 plus c, because I'm taking 0 cubed times 1/3, 0 squared, 0. Okay, so I find out that 4 is equal to c. So again, I'm going to go up here and say y squared is equal to 1/3 x cubed plus x squared plus 4. We're not done. What you need to do on this one is you need to say, well, I'm finding the particular solutions, which means I actually have to get y by itself. So I'm going to take the square root on both sides. But remember when you're introducing the square root that your answer can either be positive or negative? This is only going to be one of those things. You have to go back to this original problem when f of 0 is equal to 2 and consider which one of these would make it true. Meaning if I have y, and I took 1/3 x cubed plus x squared plus 4, if I substitute in 0 and I get a positive 2, this square root would have to be positive. That's my answer. So I'm going up to this original point and making sure that my positive value makes sense. Let's do another one. Okay, you start this one, see if you can do it. Get y's on one side, x's on the other, go through this process. If you're like, nope, can't do it, follow along with me. Okay, y dy is equal to x plus 2 dx. Integrate both sides. I have 1/2 y squared. Over here, 1/2 x squared plus 2x plus c. I'm going to substitute in for x and for y. Some people might have also solved this a little bit sooner here and like solve this for y. It's okay. I'm just substituting in right away so I can find this value of c and it's not as confusing later. So I've got -3 squared. X is 1. This would be 9/2. This is 1/2 plus 2. I could put these together and then do something with this, but I'm going to actually subtract 1/2 from both sides. So I'd have 8/2. That's nice. It's equal to 2 plus c. 8/2 is the same thing as 4. 4 minus 2 is 2. Then I'm going to go back up here. I have 1/2 y squared is equal to 1/2 x squared plus 2x plus c, or in this case 2. If you solved for c at a different place and you're like, you know what, a c is a constant and there are different values you could have gotten to c, but you should have the same final equation as me. So here I'm going to solve for this, get y by itself, so multiplying everything by 2, I would have x squared plus 4x plus 4. Square root both sides, but remember this is plus or minus, I'm not sure which one. Check. If I substitute in x is 1, I get a -3. The only way to do that is if this were whole square root was negative, so that your final answer is negative. Okay, check your work with mine. Go back through this video as needed. Okay, so far I'm hoping that you're thinking that maybe this is easy peasy lemon squeezy, or at least bearable lemon bearable. I don't think I've ever used that phrase before, but it probably is a common phrase, so I probably just missed it. Then these two throw a little bit of a wrench in things if you can remember an exponent rule. So like, or if you can remember this rule, it's not so bad. But we're going to need to know this little rule up here. So I'm going to say there's a log exponent rule. This was just supposed to be a star. That doesn't really look like a star. I don't know how to fix this. Okay, so the log exponent rule is bx times by is equal to b times x plus y. And we actually use this all the time. Think about like x to the first times x to the first is x to the second. We use this rule all the time, but we're going to use it specifically here. Okay, so I've got dy dx, and I've got this, and you're like, oh, not so bad at all, but you'll see where there's an issue in a second. This one, I'm going to multiply both sides by dx. So I've got dy, x to the fourth, y minus 2 dx. And then if you're looking at this, you're like, this is kind of gross. There's a y minus 2 over here, and I know it has to be on this side. So I'm going to divide both sides. So now I've got 1 over y minus 2 dy is equal to x to the fourth dx. I've got my y's on one side, I've got my x's on the other. Now I can integrate. Think about what is the antiderivative for 1 over y minus 2. Many of you might have said, well, this is y minus 2 to the negative first power. Add 1 to my exponent, divide by my new exponent. Ah, you can't divide by 0. When in doubt, natural log. The antiderivative of 1 over y minus 2 is the natural log of y minus 2. And I'm putting the absolute value just because you can't ever take the natural log of a negative number. So I'm restricting the domain by doing this. Y minus 2, there was a problem a few years ago in an AP exam that was pretty mean, so I'm just saying it here. It was 1 over, and I think that it was 2 minus y over here, which then it wouldn't just be the natural log of 2 minus y. You would have to divide by the derivative of the inside. So the problem was like this instead. It was 2 minus y, which the antiderivative of this is not natural log of 2 minus y. You have to remember that the derivative of the inside is -1. Divide by -1. Anyway, that's just a fun fact. This was from a few years ago, but just so you know that. Okay, on the other side, so you might be thinking, this doesn't sound too bad, so why were you saying this is a little hairy? Okay, the reason why it's a little bit hairy is because we have to get rid of this natural log first, because even though I just said, well, you can't just take a natural log of a negative number, so I put the absolute value, it doesn't quite work that way where we can just say, oh, it's just going to be natural log of 2 instead of positive 2. What I need to do is get rid of this natural log altogether before I substitute. So now I have this. E to a natural log will go away. Now I've got e to the 1/5 x to the 5th plus c. If I would substitute in 0 and 0, so 0 over here, 0 over here, I am not any closer to finding what this is, because I'd end up just needing to take the natural log of both sides again, and then I'd be in the same boat as I was up here. So I'm going to use this little rule that x times something times x times something is x squared, x to the first times x to the first is x squared, or I can say if I have like bases, it's the same as b to the x plus y, but I'm going to go backwards. Do you see how here I've got a base of e and it's something plus something? So I know I can separate it into like bases, like this. So I feel like this part is where the math magic is happening, and that's where it's really important to know this rule. That star was a little bit better. In this one, I need to separate it. And you might think, that doesn't really get me any closer to knowing what's going on here. But if I can put in 0 and 0 now, 0 minus 2, e to the 1/5, 0 to the 5th, times e to the c. I don't have to get e to the c by itself. I can just solve for this whole quantity. Sometimes there are free responses that if you're looking at what the solutions are, they will change this value to k. If you ever see that, that's what's happening here. But this, we can just keep it as e to the c, and instead of solving for c, I'm going to solve for e to the c. So I've got 0 minus 2 is -2. E to this would be 0 to the 5th would be 0, times 1/5 is 0, e to the 0 power. Anything to the 0 power is 1. So -2 is e to the c power. So I can come back up here and I can say, well, y minus 2 is equal to e to the 1/5 x to the 5th. And instead of solving for e to the c, I'm just going to say, well, I know e to the 5th is -2. Or, I'm sorry, e to the c power is -2. I just solved for that here. I don't know why I said 5th. There we go. So I have this here. Last step. Add 2 on this side and on this side, and I'm going to put the -2 coefficient in front. So I put the -2 out in front here, out of 2 in the end. Ta-da! This next one is kind of similar to this, actually. If you feel like you're ready to try this one on your own and you just keep this rule in your head, do that. If you're like, following along with you, you do that. Or if you have a little bit of both, that's okay too. So I'm going to multiply, oh man, this is gross. If I get the dx on this side, I've got dy is equal to, I'm going to write this out a little bit differently. I can do that, right? So all I did was rewrite what was up here and then multiply both sides by dx. Now I'm going to divide. Ooh, this is exciting. It looks a lot like my other one so far. Now I'm going to integrate both sides. On the left-hand side, the antiderivative of 1 over y minus 1 is, you're right, this is another natural log. On the right-hand side, the derivative of 1 over x squared is, it's not a natural log. Think about it, if you rewrote that like this, I can do traditional rules here. I can add 1 to the exponent, divide by my new exponent, plus c. And then I would probably rewrite this just so it's a little bit easier to deal with again, because I know I'm going to be substituting in soon. This would be the same as negative 1 over x to the first power. Because this makes the whole thing negative, the negative exponent drops the x to the denominator. If you put in 2 and 0, 0 minus 1 is still a negative 1. I don't want to deal with negatives over here, so I'm going to raise both sides. I'm going to say e to both sides. So e to something, e to something. E and the natural log go away. I would have y minus 1. Over on the right-hand side, this is where the same business that was happening over here happens again. I want to rewrite this as e to the negative 1 over x times e to the c power. So I'm doing that special rule that was up here, the log exponent rule. There it is. Down here. Now I can substitute in x is 2, y is 0. And this is where it gets a little bit tricky, but it's okay, bear with me. This would be the same thing as negative 1 is equal to e to the negative 1/2 is the same thing, and there are multiple ways that you can do this right here, is the same thing as 1 over e to the 1/2, or you could say 1 over the square root of e. There's lots of different ways to say this. To get this to the other side, I'm multiplying both sides. Negative e to the 1/2, also known as negative square root of e. So if you have it like this, that's fine. If you said, no, I know it's this, that's fine. Whatever. As long as you take one of these, and then when you go back up here, you substitute it in. So I've got y minus 1 is equal to e to the negative 1 over x. And yes, you could even write that as 1 over e to the 1 over x. There's multiple ways to write this, and it's okay however you decide to, as long as it's an equivalent expression. And then you would multiply it by negative square root of e, or again, negative e to the 1/2 power. The last step is just to add 1 on both sides. So I'm going to write this negative square root of e, because I can, times e to the negative 1 over x plus 1. If you're not sure if your answer matches mine and you just want to be sure, you can take this into your graphing calculator and put this in for y1, or in Desmos you can put it in y1 or whatever, any graphing application. Put this in y1, put yours in y2, and then what you want to do is make one of them bold so you can see if there's a line exactly over it. So just graph it and see, are you graphing the same line? I actually, I've given a test in the past where this is one of the problems on there, and that's how I do it, because there are so many different ways that you can write this that I just have my answer in my graph, and then I just graph each person's answer to see if they match up, because there are different ways that you can write this. Okay, we did it, and I don't know if you noticed, but this page could make you so many friends. Look at this. Look at how smart you look. It's because you are smart, but also look at what we just did. So good. I hope your day is even better than how awesome this is, and will make you lots of new friends. Yeah, I don't know what I'm saying. I hope your day is awesome. Thank you for listening. Thank you for learning. I appreciate you. Please let me know how I can help you.